So I've talked a lot about grass in GameMaker on this YouTube channel in recent days, and we've done some fun things with it. We've made the grass shake back and forth when the player runs through it. We've made the grass just sway in the breeze, which I think is a nice atmospheric effect. And there's one more thing that I would like to talk about with regards to grass here today, and that is going to be making it run fast. So the subject of performance is an ever fun one. This is occasionally a bit of a hot button issue in gaming. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and today we are going to run through the code that makes these grass objects work in order to make it just a little bit faster. So, before we get started, there's a couple of ground rules. Whenever I talk about optimization in GameMaker, there's a few things that just have to be said. I'm not going to give the whole speech today, but one, things to keep in mind, GML is slow. That is just the current state of affairs at the moment. You can use the YYC to get somewhat of a performance boost, but we're going to be treating that like icing on the cake. We're not going to just be leaning on the YYC to make our code faster. Two, GML is actually not as slow as you might think. It can do a lot, as long as you don't behave irresponsibly with it. And it cannot be overstated that it's much more important when optimizing your GameMaker games to look at what your code is doing as a whole, and to not focus on individual lines. Three, we are going to be worrying about CPU performance today and not GPU performance. In the grand scheme of things, we're going to be drawing a lot of grass sprites, but a lot of grass sprites is still going to just be probably a couple tens of thousands of triangles. And even fairly old entry-level GPUs in the modern day can handle millions of triangles without problems, especially if you're not doing any complicated lighting calculations on them, which we are not. And fourth, and probably most importantly, there is not, never has been, and never will be a one-size-fits-all optimization in a game, GameMaker, or otherwise. When you sit down to do this, you are going to have to actually look at what your code is doing. You're going to have to think critically about what it's doing. You're probably going to hear me say several times in this video that the optimizations that we employ on making grass faster will not necessarily work if you just transplant it onto something else in your game. And as a bit of a corollary to that, there are also other optimization strategies in GameMaker that you could employ here, but I'm not going to talk about because I don't want this video to be an hour long. And I want to make this video about actually the grass and not just general GameMaker optimization advice. So are we good? Alright. So let's get started. To set things up, there's a couple things I'm going to do here. One, there are 1,000 grass objects in this game. That's a lot. It's already filling most of the screen when I run around. And like, you could make the grass objects smaller or zoom out the viewport, higher resolution viewport, and you could fit in more grass that way. But I think this is, we can probably safely say that at least for this art style, this is probably as much grass on screen at once as you're really going to want. So because of that, I'm going to go into the room editor, and I'm going to dial up the amount of grass from 1,000 grass objects to 15,000 grass objects. And the reason that I'm going to do this is not because this is in any way realistic. This doesn't even look like grass. This just looks like noise. I can't wait to see how the YouTube video compression treats that. We're going to be dialing up the amount of grass in this game, not because it's like a realistic and normal thing to want to do in your game, probably, unless your name is Ace Rolla, in which case, how did you find my channel? That's interesting. I'm doing this because I want the frame rate to really be something that you feel instead of just being something that you see on like debug readouts or something like that. So, because this is a little silly and because I do want to actually be able to see the grass, I'm going to go and increase the room size from, let's say, 640 by 360 to like 2800 to 2000, and that is going to make the game room several dozen times bigger. And given this, you can probably already think of a way that you can make this faster that we're not going to talk about today, because again, we're going to talk about the actual grass and not general GameMaker optimization advice in this video. And now when I do this, we're going to have 15,000 grass objects, and they're going to slow the game down to honestly, this already runs better than I thought it was going to. I was expecting like high teens, low 20s FPS when I did this, but instead we're getting high 20s, low 30s. Alright, again, something you feel. Do I want to be more adventurous? I'll be a little more adventurous. We're going to go up to 20,000 grass objects. This is going to bring my 9950X to its knees. And we'll see if we can get to 60 FPS here. I'm not sure if we'll get all the way to 60, but we should be able to get pretty close, I think. Anyway, next order of business is we are going to actually figure out what in this game is actually making things slow down. And to do that, we are, of course, going to employ the debugger's profiler. So if you've never seen this before, the profiler is amazing. You can find it by going into the debugger, running your game in debug mode. You can go, if it's not in one of these tabs at the bottom, you can go to debugger up here, Windows, and open the profiler. And that's going to open up this little chart, which you can use to figure out what in your game is taking the most amount of time to execute. I'm not going to go into too much detail about the profiler. I have made dedicated videos to it in the past. But let's go and start profiling, and we're just going to let the game sit here for a few minutes. And that's gonna run. It's not gonna run well. Running the game with the profiler on will actually drop your frame rate in and of itself, because some extra time is being taken to actually like query the game and see how long individual function calls are taking, which isn't free. But we are going to stop that after a couple of seconds. I'm gonna get rid of step percentage because it's not really useful here. We can sort the time that it takes individual pieces of our game to execute in milliseconds from high to low. And when we do that, I'm going to close this because I don't really need that wasting CPU cycles in the background while I do this. I'm going to sort the frame times from high to low. We can see that the grass draw event is taking up by far the most time in the in each frame. We can expand this to see exactly what inside that is taking the most time. And by doing this, we'll notice a few things. One is that the 4 entries within grass draw here do not add up to the total time, and that's because GameMaker doesn't actually profile like individual arithmetic operations. It only profiles actual function calls. And there's some hand waving going on there because like internally to the runtime, arithmetic operations are function calls, but we're going to pretend that's not the case here. Sprite get UVs, draw sprite position, cosine, and sine are the only individual function calls that it's going to track. And the second thing you might notice, and this is probably where a lot of people's minds are going to go first, are that sine and cosine are actually extremely cheap relative to GameMaker. So I don't want to make it sound like sine and cosine being extremely cheap are like a fundamental fact of the universe, because whenever I do that, I get a lot of weird comments. But because this is GameMaker, and because GameMaker as a whole is like not the fastest, sine and cosine are proportionally much less of a thing to worry about than they would be if you were running this in like pure C or something like that. And for the most part, there's not really much we can do here to get rid of these. If you try to optimize out sine and cosine, you are likely going to end up with something that's actually slower than what you started with. We are going to focus on everything else. So sprite get UVs right off the bat is not like an overwhelmingly large chunk of frame time when we do this, but it is going to be 2.25 milliseconds out of 38. When we run this. Like I said at the beginning, it is important to actually, let me bring this down somewhere like down here. How about into, can I go stick it in the others tab so that it's just there? There we go. So let's think about what this is actually doing. So this sprite get UVs function is a function which is going to return certain pieces of information about individual sprites, specifically individual like sprite frames. And we're using that so that we can account for any and all automatic cropping that GameMaker might apply to sprites when it's written to the texture page, so that we can feed the correct sprite positions into draw sprite position, which we can move horizontally to get the little wave effect. And for any given sprite index, image index inputs into the sprite get UVs function, the output is not going to change. It is what mathematicians might like to call a pure function, in that the output value only depends on the inputs. It doesn't depend on like the state of the game or anything like that. It doesn't like change the state of the game, God forbid. And because our grass is specifically drawn with the same sprite index, same image index, like it doesn't change, it doesn't mutate over time or anything like that, we don't actually need to fetch this data every single frame. What we can do instead is we can take this and we can stick it in the create event, and we can make it an instance variable instead of a local variable, and it will make no difference to how the game actually looks. If this is just calculated once in the create event and hung onto, or if it's calculated in the draw event. But if we just do this in the create event, we can get the 2.25 milliseconds that it took to do that back for basically free. So if I run this again, we might not see like exactly the same timings as we did the first time, because it did seem that like it got cut off in the middle of a frame, hence being like 20,500 calls instead of like 20,000, which is what you would think it would be. I don't know. Sometimes GameMaker's debugger does that, but it's only going to change the result by 1% or 2%, so we're not going to worry about it. Anyway, if I do this, that 2.2 milliseconds for that sprite get UVs function call, that's gone, and we can see that it has accordingly been subtracted from the total amount of time that it takes to render a frame. And now instead of getting, I'm going to stop profiling. Instead of getting like low 20s FPS or whatever we had, instead of the total frame time taking about like 50 milliseconds, we're going to be... I see it seems to have stopped profiling in the middle of a frame again because it's got like 20,300.96 call count. GameMaker, it's really confusing when you do that. Anyway, we got about 2 milliseconds of frame time back, basically for free. And the game looks basically the same as it did before. So, with that in mind, let's look at the next couple of lines of code that are running here. So, again, because we're looking at grass, and grass has a tendency to stay still and not walk around and not, like, drastically change its size and shape over the course of just, like, a couple of seconds. Things like image X scale, image Y scale, sprite width, sprite height, for these particular grass objects, that is also something that is not going to change ever, like, during the, like, runtime of the game. And that is also something that you could just pick up, move to the create event, and turn into an instance variable. And now, we can still reference this crop left, crop top, crop right, crop bottom, those variables as instance variables instead of as locals. This is definitely one of those things that I mentioned that, like, if you are not dealing specifically with grass objects and you're dealing with, like, I don't know, a character who gets up and walks around and changes size and shape, this will not work because when we just look at our X scale, Y scale, sprite width, sprite height in the create event, if you ever change these at runtime, then these values are not going to update automatically unless you go out of your way to do it yourself. Fortunately, vegetation, when it grows, usually grows a little bit slower than that, so we're just going to pretend it doesn't grow at all. And if we run the game now, and if we go into the debugger, again, it looks pretty much the same as it did before. It waves back and forth pretty much the same as it did before. Let me go into the profiler, start profiling, and we can now see that none of the individual, like, function calls inside obj_grass_draw0 have changed, but we've now gone down from 34 milliseconds to about 28 milliseconds in total for each frame. For 20-something thousand grass objects. So that's pretty interesting. Let me stop that now. And let me close out of that. What was this originally like? 38 milliseconds, something like that. So we've gotten back about 10 milliseconds for basically free. Just by moving code to the create event. So that brings us to this next block of code. And this next block of code is probably more heavy than the other two things we've done put together, just because there's, like, more of it. And these two here, x3, y3, and x4, y4, these are the bottom coordinates of the sprite. These don't do anything especially interesting. We can just also move these over to the create event here for free. The top corners of the sprite, so x1, y1, x2, y2, that's a little bit different because we are actually basing this off time offset, which is a variable that does change frame to frame. That is what, after all, drives the wave. But if we were to eliminate this from here, if we were to, like, factor these out, let me just remove this, and we'll get back to that in a minute. If we were to move those 4 values to the create event as well, and make those instance variables and run the game, we would be able to see that the grass is not going to move, which is kind of defeats the whole point of what we're doing here. We did get some performance back, but, like, the grass isn't moving. And instead of just moving those values over and that being the end of it, we are going to want to now, let me put each of these function arguments to draw sprite position on its own line, because there are quite a few of them and I don't want them to get lost. We could instead just add time offset back into x1 and x2 over here. When they're passed as parameters to the draw sprite position function. And this is going to perform about the same as it did before, but we are going to have the grass wave back. Technically, it's not going to perform the same because we are doing a couple of addition operations here. But again, we're not going to worry about individual math operations as much as we're going to worry about, like, batches of code that do things that maybe they don't need to do. And now we can run around. We've got about mid-30s FPS here if I run the profiler. Let's see what that comes out to. It's probably going to drop to maybe, like, low 30s. All right, high 20s when I run the profiler because, again, actually the act of profiling your code does, you know, have a non-zero cost. But we can stop that. We can look at our frame times again. And now our obj_grass draw event is cut down almost in half. This is almost half of what it was when we started. So we are going to be looking at about 20 milliseconds of frame time being dedicated to just drawing the grass. And making the grass draw twice as fast, I think, is a pretty good place to be. Now, beyond this, in the draw event of the grass, there are a couple of items of diminishing returns that you might look at. Individual bits of code like this x over 50 plus y over 50, this like position hash of the grass. This doesn't change because the grass doesn't ever move around. You could move this over to the create event as well. We can call this like position hash or something like that. And we could add that into the cosine function here instead of calculating that ourselves. This really isn't going to change much. It's probably going to have about as much of an impact as adding these two terms back into the draw sprite position coordinates did overall. You can do it if you want. I'm not going to stop you, but like don't expect any miracles. Yeah, we're still looking at 18 or so milliseconds here. That's probably more to do, honestly, with the fact that like when I stopped last time, it was profiling like in the middle of a frame, and it had like 21,000 calls instead of 20,000 or whatever. Anyway, that's really getting into the micro optimization territory. I would not spend a lot of time worrying about that. Likewise, current time divided by 1,000 is going to change from frame to frame, obviously, but it's not going to change between individual grass objects. You could take this out, put it in some other location, calculate it once, and just reference it. That's also really not going to make much of a difference. I'm not going to lose sleep over doing that. What I am going to lose sleep over is if we move down to the next item in this list. obj_grass draw event is still obviously the most expensive part of any individual frame, but we have at this point really done about as much as we can without just removing grass objects or just using the Yoyo Compiler or other things that I said I wasn't gonna address here. And if we go down into the step event of the grass objects instead, we can see that there's a little bit going on. So event inherited is taking up 3 milliseconds, 3.5 milliseconds of frame time here. Let's call it 3 because, again, I don't know why this call count is weird like that. Anyway, 3 milliseconds of frame time is a decent chunk, and a lot of it's just going to event inherited here. As it happens, there isn't actually much happening in this event inherited, so the way that I have this project set up, and this is something that I can take advantage of because of the way that I have set up this project. This might or might not be something that is also applicable to your project. If I look at the inherited end step event, all that's actually happening is some depth sorting, depth equals -y. And that is, again, something that isn't something that's really going to be useful in the step event of a grass object because the grass doesn't move. You don't need to update that every frame. And if I take that out, and if I just do the depth sorting, depth equals -y in the create event, and if I were to get rid of the inherited event call, that is also going to claw back a couple of milliseconds. And where are we? We're at high 30s, low 40s FPS now. We are getting higher in the frame rate, so this is the point where like making the same, like cutting out the same amount of frame time is going to start leading to noticeably higher frame rates, at least in terms of numbers. If I run around now, it still doesn't feel like 60, but it definitely feels a lot better than like 20. I don't happen to have a variable refresh rate screen, so I can't really make use of like 40 or consistently 40 or 45 FPS. You might be happy with that, but I'm going to try and get this a little closer to 60. Let's see. Did I actually profile that? I don't think I did. I didn't actually profile that when I was running around, so let's try that again. All right, let's say start profiling, let it run for a couple of seconds. We have cut down our grass step event from, what was it, 7-ish milliseconds on its own to about 4 and change. All right, that's pretty cool. So most of the amount of time spent in this step event here is unaccounted for, and a lot of it is just going to be this. Again, this is only a couple lines of code, but when it's running for 15,000 objects, that will start to add up a little bit more significantly than it would if it was running for just like 1,000 or 2,000 objects. There is another item of interest here, however, which is place meeting. Place meeting out of this total is only really accounting for apparently 3/4 of a millisecond of frame time, which is comparable to the time that it takes the sine and cosine functions to run. So normally this is not something I would really spend a lot of time looking at if my game was running slowly, versus operations that just have like a much more substantial impact on frame times. But there is a little bit of general advice, and again, there's no universal truths when it comes to optimizing games in GameMaker or elsewhere. But generally, place meeting isn't like horrendously expensive here, but simply checking if the player object has moved since the last frame is less expensive. And if you were to first check if the player has moved since the last frame before doing the place meeting check, you would get back a small amount of performance. Not like a lot. Again, don't expect miracles, but we might be able to chop out maybe half of a millisecond of frame time just by doing that. And indeed, we are down to 1 point something instead of whatever we had before. Don't really remember. Oh, that was I'm not looking at the right one. All right, it's down to like 4, down from like 4.2. Okay, so probably statistically significant, but not really going to go a long way to getting us to 60. Another thing you can do to take this a step farther is, and this is also probably not going to really make a huge difference, but we could rearrange this further, and instead of doing this collision check inside the grass object, we could move this to the player object. And the reason that we would maybe want to do this is because if I put this in the player step event, this logic is only going to run once. And we can get rid of the obj player dot references here, I think, because we're running within the scope of that. If I put this logic here, this is just going to run once, whereas if I put it in the grass object, it was going to run 15,000 times. And when I say that, I don't mean like this entire block of code, which has some fairly... it's not complicated, but it is long. Like this whole thing obviously wasn't going to run 15,000 times, unless the player was somehow like running around and touching every single piece of grass in the game at the same time. But simply removing that from the grass step event entirely might be useful. We are going to have to actually, again, think about what we're doing here, and we're going to have to basically reverse the perspective that we're looking at this code from. So instead of being in the perspective of the grass object and we're checking for collisions against the player, and if there is collision against the player, we do something with the grass object. We are going to look at this logic from the perspective of the player, and we're going to check for collisions against the grass objects. And we are going to have to change things around here to make this work. So instead of just looking for a true or false, are you touching the player, we are going to need to take this out, and we are going to need to check for collisions against the grass objects. But this place meeting function is just going to return a true or false. It's not going to return a reference to a grass object or anything like that, an instance ID. But we're actually going to want to do that, and this is kind of a problem because GameMaker has like a dozen different collision checking functions, and they all do sort of the same thing, but not quite. Let's use a function called instance place instead. And this is going to return a reference to an instance ID of a grass object if it finds one. If it doesn't find one, it's going to return just a null value. And we can say if instance exists grass, we can then say like with the grass object, we can run this logic. We can also just, if we didn't want to use the with statement here, we could say like grass.player offset equals this, grass.player offset time equals this. And we could make our code look like this. It doesn't really matter. However, this will have a slight problem in that we will only now be able to check collision against one piece of grass at a time instead of, a whole bunch of it at a time. And to make this function return hit results for a bunch of grass objects at once, we could use a different version of it called instance place list. And this is a function which will take a DS list, and it will insert the hit results into the DS lists. The last parameter to this instance place list function is ordered, which is if you want them to be sorted in order of distance to the player or not. I'm going to say false because we don't need that. We are going to want to, at the end, DS list destroy. And we will, instead of just This function now is going to return the number of hits, so the number of objects that are in the list now, by the way, which I suppose might be relevant. Anyway, instead of directly saying like grass.player offset equals whatever if a hit is found, we can loop over. We can loop over the grass hits list and say our individual grass object is going to be list index I, and following from that, the rest of our code can stay the same because we have a reference to a grass object. We're just now iterating over a list of them instead of looking at them individually. And this is, despite having moved a lot of code out of the step event for the grass, this is not going to make a huge difference, but it will make some amount of difference. And let me just check to make sure that it behaves the same as it did before, and it looks like it does. And if I bounce back over to the profiler, we can start profiling our game. And our grass step event is now down to about 2 milliseconds of frame time instead of 4. So that's definitely better than it was before. If I stop profiling, we can, well, I guess we can't take a closer look at it because we can't, we no longer have any individual function calls inside this. But we can see that if I do this, our frame rate is high 30s, which is actually not that different than it was before, probably because I am still running it in debug mode, and there is also a slight amount of overhead from debug mode. It could also, honestly, just because I've been doing this for so long now. Alright, so in not debug mode, we've got 45 FPS. It could honestly be because I've been doing this for so long and my CPU is a little warmer than it was a half an hour ago. Anyway, let me see. So there are... those are the main things that we can do to make this faster. So we've chopped our frame time down from like 45, I think, milliseconds per frame to something like, at least between the step and draw events, 20-ish. So we've cut it down more than half. There are other things you could do to squeeze a little bit more out of this here and there. Again, like pre-computing this somewhere else and referencing it. There are other things external to the system that you could do to speed this up, such as like object culling, which is a whole other can of worms. In some cases, if you really, really wanted to get really extreme with it, there are some like black magic, like super arcane tricks you can do to take this out of the player step event, store it somewhere else, and like reference that over here instead of storing them as object variables. But that is the sort of thing that, like, if you're not careful about how you can do it, it can make performance worse instead of better. And actually making that run fast usually involves writing some code that's really, really not very clean, which I don't know if I want to encourage people to do today. So I think we'll leave it there. I just realized that there is no space between this player offset direction and that multiplication there, and it was really bothering me for reasons that I can't quite put into words. Lastly, let me actually run this with the Yoyo Compiler and see how this performs now. I don't expect it'll be much because we have removed most of the actual like logic from the end step and draw events here, and most of what is going to be left is going to be stuff like the actual like draw sprite position and stuff like that. I see we're about up to, we're hovering around 60. We're not quite up to 60. It does look pretty smooth to my eye. If you're the sort of person who's really, really sensitive to hitches and stuff, you might notice a couple drop frames here and there, but for the most part, it looks like we got to 60. All right. And this does seem to be about the upper bound of how much grass I can have at once in the scene on this computer without dropping. Your results may differ. Again, my CPU is fairly big. If you're running this on like a laptop or something, you might run into limits sooner. What else do I want to do? You know what? Because this just occurred to me. I haven't actually tested how this behaves in GMRT. So for those who don't know, you can think of GMRT as GameMaker Studio 3. It's just not named that for reasons that I won't get into today. And I'm curious. Generally, GMRT performs a little bit better than current runtime. We don't actually have any FPS readouts here because the performance profiler is like not working. And I don't know why. Okay, let me go and just draw that on the UI myself then. We can just draw text FPS_real. So, I said a minute ago, anyway, that GMRT is usually a little bit faster than current runtime, but there are some exceptional cases. I see now it looks like we're getting more like 40, upper 40s to 50 FPS, which is a little slower than it was before. And it's also highly unstable, meaning that code that just works normally just may or may not randomly explode at random moments in GMRT, so it's really not recommended for anything besides, like, experimentation at the moment. Anyway, if I run this in GMRT native, which is basically its equivalent to YYC, we're getting about the same. Not much of a difference there. Alright, that's fine. At some point in the future, Yoyo Games has not really done much by way of optimization in GMRT yet. I was just curious. Come back in a year and the results will probably be very different. So I think that's it for optimizing this system. We did a lot. We've removed a lot of, like, redundant calculations. And I think I'm going to end this off here. So, my name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the GitHub repository down in the description of this video. Feel free to try to juice this farther. I'm sure some people will get creative with ways that they can eliminate this and get back another couple of milliseconds here or there. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I do like to make videos on weird stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Die Games, Pixelated Pope, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, and Bokeh Dev for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.